Today, we're going on a digital hunt. We're looking for a new way to fight one of the world's biggest health crises. And what's so cool about this story is how it blends ancient wisdom with some seriously futuristic technology. The clues? Well, they're hidden in a place you'd probably never expect. Just take a look at that number for a second. 537 million. That's how many adults around the globe are living with diabetes right now. And honestly, it's on track to get much worse. We're talking nearly 800 million by 2045. It's a huge problem, and that's why scientists are getting creative and looking for solutions in some very old places. And that really brings us to the core question of this whole thing. What if the answer to this massive modern health problem isn't something we have to invent from scratch in a high-tech lab? What if it's been hiding in plain sight all along, tucked away in traditional remedies passed down for generations? So, our story starts with a fantastic lead, an ancient remedy from Nigeria. And we're not just talking about folklore here. This is a real practice that communities have trusted for years. Okay, so this is it. This is the leaf from the Daniellia oliveri tree. For a very long time, local communities in Nigeria have been using these exact leaves to help manage diabetes. But here's the thing. While the tradition is strong, the hard scientific evidence has been pretty limited. Well, until now, that is. So how do you even begin to test something like this? How do you take a traditional remedy and stick it under a modern scientific microscope? You've got to take it from the leaf to the lab. The researchers followed this super meticulous four-step trail. First, they basically soaked the dried leaves to extract all the raw chemical compounds. Think of it like making a really, really strong tea. Then, they used different liquids to sort those compounds into groups. After that, they purified those groups even more. And finally, this is the really cool part, they used a high-tech machine to get a precise chemical fingerprint of the most promising ingredients. And this diagram here, it shows you the whole workflow. You can actually see the journey right from the physical leaf, through all the lab gear, all the way down to the individual molecules that a computer can then analyze. This is literally the bridge that connects that ancient wisdom with modern digital science. Now, this is where things get really futuristic. I mean, this is the kind of stuff you see in movies. Instead of jumping right into animal or human testing, the scientists did the first round of tests completely inside a computer, a virtual drug trial. This whole method is called in-silico evaluation. It sounds complex, but it's really about using powerful computer simulations to predict how a drug might work in the human body. And think about what that means. It's way faster, it's way cheaper, and it significantly reduces the need for animal testing. It's a total game changer. The heart of this virtual trial is a technique called molecular docking. And honestly, the best way to think about it is like a lock and a key. Your body has these proteins that can cause or contribute to diseases. Those are the locks. The different compounds from the plant leaf? Those are our keys. The computer's job is to simulate trying every single key in that lock, over and over, to see which one is the perfect fit, to block that protein and stop it from causing trouble. All right, so after running thousands of these digital tests, what did the computer find? Did any of our ancient keys actually fit the modern locks? Well, the analysis pointed to 8 main chemical suspects. And you might even recognize a name on that list, salicylic acid, which is basically the active ingredient in aspirin. But when the computer ran all its simulations, one key looked especially good at fitting the lock for diabetes. And that was a compound called gallic acid. And this chart, wow, this really tells the story. What you're seeing is a comparison between the plant compounds and acarbose, which is a standard prescription drug for diabetes. And the results are just striking. The compounds from the Daniellia oliveri leaf, especially our star player gallic acid, showed incredible potential in the simulation, performing nearly as well as the conventional medication. So here's the bottom line. The science is actually backing up the tradition. The authors of the study said it themselves, that their work successfully revalidated the traditional use of these leaves. It's just a powerful moment when you see modern data confirming this kind of ancient wisdom. But, and I really want to stress this because it is so important, we have to be crystal clear. An in-silico study, no matter how promising, is not a cure. These are incredible results from a computer model. The absolute essential next step is to take these findings out of the computer, back into a real-world lab, and eventually into human clinical trials to prove that it's both safe and effective. You know, this whole journey leaves us with a pretty incredible thought. This was just one plant from one traditional remedy in one part of the world. It just makes you wonder, doesn't it? How many other life-changing medicines are already out there, not waiting to be invented, but just waiting to be rediscovered?